Picture this. It's 1976, and you're at a drag strip in Ohio watching muscle cars thunder down the quarter mile. Big blocks, high compression, lumpy cams, the usual suspects. Then a rusty Plymouth Duster pulls up to the line. Under the hood, a Slant-Six. The economy engine your grandmother drove to church. The crowd chuckles. The tree drops. And this thing launches like it's been shot from a cannon, crossing the finish line in 11.8 seconds at 115 miles per hour. The V8 guys are speechless. What just happened? What happened was Tom Hoover had just rewritten the rules of affordable performance. This Ohio mechanic had taken Chrysler's most boring engine, the one they literally designed to be indestructible but slow, and turned it into something that shouldn't exist. A 400-horsepower economy engine built with junkyard parts and pure mechanical genius. He didn't just modify an engine, he exposed a truth that Detroit's engineers had completely missed. The Slant-Six, that tilted oddball of an engine, was actually the perfect platform for forced induction. It just took a guy with a welder and a $150 Caterpillar turbocharger to prove it. This is the story of how one mechanic outsmarted an entire corporation, pioneered turbocharged six-cylinder performance in America, and created a legend that still influences builders today. Tom Hoover didn't have Chrysler's resources. He didn't have their wind tunnels or dynamometers or teams of engineers. What he had was something more valuable, the ability to see potential where everyone else saw limitations. To understand why Hoover's creation was so revolutionary, we need to travel back to 1959. Chrysler was developing a new engine for their compact cars, the Valiant and the Dodge Lancer. Ford had their Falcon 6. Chevy had their inline. Chrysler needed something different, something that would fit in a compact engine bay but still provide decent performance. Their solution was ingenious and weird. The Slant-Six got its name from its 30-degree tilt to the right. While other inline sixes stood straight up, Chrysler's leaned over like it was taking a nap. This wasn't just quirky design for the sake of being different. The slant allowed for a lower hood line, better weight distribution, and room for longer intake runners. But here's what really mattered. This design accidentally created the perfect architecture for turbocharging. The intake and exhaust were on opposite sides of the head, providing natural packaging for a turbo setup. The long intake runners that Chrysler designed for low-end torque, perfect for pressurized air. The cast iron block that was overbuilt for durability, ideal for handling boost pressure. Chrysler offered the Slant-Six in two flavors. The 170 cubic inch version made about 101 horsepower. The 225 cubic inch variant, the one that would become legendary, produced 145 horsepower in its hottest factory trim. These weren't performance numbers, they were economy numbers, and that was the point. Chrysler marketed the Slant-Six as the engine that would run forever. They were right about that part. These things were virtually indestructible. Taxi companies ran them for 500,000 miles. Industrial applications used them as stationary power plants. They had forged cranks, solid lifters, and gear-driven camshafts. The bottom end was so overbuilt it was almost comical. Chrysler had accidentally created a bulletproof foundation for massive power. They just never realized it. The performance world ignored the Slant-Six completely. Why would anyone hop up a 6 when V8s existed? The 426 Hemi was making 425 horsepower. The 446 pack was destroying everything at stoplights. The Slant-Six was for grocery getters and traveling salesmen. It was invisible to the performance community, which is exactly why Tom Hoover's breakthrough was so shocking. Tom Hoover wasn't related to the Hoover who designed the 426 Hemi at Chrysler. He was just a guy who worked on cars in Ohio and raced on weekends. But he had something most people didn't, the ability to see engineering solutions where others saw dead ends. In 1976, Hoover was looking at his Slant-Six powered Duster and thinking about the gas crisis. V8 muscle cars were becoming extinct. Insurance was killing them. Gas prices were murdering them. The government was regulating them out of existence. But people still wanted to go fast. They just needed a different way to get there. Hoover had been watching what was happening in Formula One. Renault had just introduced turbocharging to Grand Prix racing. Porsche was dominating Can-Am with the 91730, a turbocharged monster making 1,500 horsepower. Turbocharging wasn't new. It had been around since the 1920s. But applying it to a Slant-Six? That was insane. Or was it? Here's where Hoover's genius becomes clear. He didn't start with some exotic turbocharger designed for racing. He went to a junkyard and found a Caterpillar diesel turbo. Cost? $150. This wasn't some precisely engineered Garrett or KKK unit designed for gasoline engines. This was a turbo meant for bulldozers and backhoes. It was huge, crude, and completely wrong for the application, which is exactly why it was perfect. The Caterpillar turbo was a Schwitzer S2B. These units were designed to handle massive exhaust volumes at relatively low pressures. On a diesel, they'd make maybe 15 psi of boost. But diesels run compression ratios of 17.1 or higher. They're designed for boost from the factory. The Slant-Six ran 8.4.1 compression. It wasn't designed for any boost at all. Hoover didn't care. He saw what others missed. The Slant-Six's architecture was accidentally perfect for forced induction. The first challenge was packaging. That Caterpillar turbo was massive, about the size of a volleyball. Hoover couldn't use any off-the-shelf parts because they didn't exist. Nobody made turbo manifolds for Slant-Sixes because nobody was stupid enough to turbocharge a Slant-Six, so Hoover built his own. He took thick wall steel tubing, probably Schedule 40 pipe, and started cutting and welding. The exhaust manifold he created was a thing of brutal simplicity. 6 tubes merging into a collector, feeding the turbine housing. No fancy equal-length runners. No merge collectors designed by computers. Just pipes welded together by a guy who understood flow dynamics through intuition rather than CFD analysis. The intake side presented different challenges. The Slant-Six used a long-runner intake manifold that curved over the valve cover. Great for naturally aspirated torque. Terrible for boost distribution. Hoover could have used the stock intake, but he understood that pressurized air behaves differently than atmospheric air. He needed equal distribution to all 6 cylinders. He needed volume to prevent pressure drop. He needed strength to handle boost without exploding. His solution was elegantly crude. He fabricated a log-style intake manifold from steel tubing, basically a big pipe with 6 runners branching off to the intake ports. It looked like plumbing because it basically was plumbing, but it worked. The large plenum volume acted as an accumulator, evening out, boost pulses. The short, equal-length runners ensured each cylinder got the same amount of boost. The thick steel construction could handle 30 psi without flexing. Now came the real challenge, fuel delivery. In 1976, electronic fuel injection was exotic technology found only on European luxury cars and Corvettes. Everything else used carburetors. But carburetors don't like boost. They're designed to work with vacuum, not pressure. Blow pressurized air through a standard carburetor, and fuel goes everywhere except where it's supposed to. Hoover needed a blow-through carb setup. He started with a Holley 650 CFM 4-barrel. This was already overkill for a naturally aspirated Slant-Six, but under boost, it would be perfect. The problem was sealing it. Carburetors have vents, passages, and openings that assume atmospheric pressure. Under boost, fuel would spray out of every orifice. Hoover had to seal the carburetor in a pressure box, ensuring that the fuel bowls saw the same pressure as the intake manifold. This meant fabricating a custom enclosure, rerouting vent lines, and modifying the throttle linkage to work through a pressure seal. The fuel system needed major upgrades too. The stock mechanical fuel pump was designed to feed 145 horsepower. Hoover was aiming for 400. He installed an electric fuel pump capable of maintaining pressure even under heavy boost. The fuel lines were upgraded from 516 to 102. The fuel pressure regulator was referenced to boost pressure, increasing fuel delivery proportionally with boost. Every component had to handle not just more fuel, but pressurized fuel. Then there was ignition. Boost pressure dramatically increases cylinder pressure. Higher cylinder pressure makes it harder for spark to jump the plug gap. The EO stock ignition system would misfire under boost. Hoover upgraded to an MSD-6A ignition box capable of delivering multiple sparks with enough voltage to fire even under 25 psi of boost. The distributor was recurved to pull timing as boost increased. Too much advance under boost equals detonation. Detonation equals destroyed engines. But the most critical modification was something nobody could see: the head gasket. The stock composite gasket would fail immediately under boost. Hoover used a copper head gasket, probably 0.060 thick. Copper can handle extreme pressures and temperatures. It conforms to surface irregularities. It actually gets better with heat cycles. But it requires perfect surface preparation. Both the block and head had to be surfaced to near-mirror finish. Any imperfection would create a leak path for combustion pressure. When Hoover first fired up his creation, it must have sounded apocalyptic. The huge turbo would have been silent at idle, then gradually spooling up with an industrial whine as RPMs climbed. By 3,000 RPM, it was making boost. By 4,000 RPM, it was making serious boost. By 5,000 RPM, it was making power that shouldn't have been possible. Let me put this in perspective. A stock 225 Slant-Six made 145 horsepower at 4,000 RPM and 215 lb-ft of torque at 2,400 RPM. Hoover's Turbo 6 was making 400 horsepower at 5,500 RPM and over 450 lb-ft of torque at 3,500 RPM. That's a 175% increase in power from an engine designed for economy, using junkyard parts. The transformation in performance was staggering. A stock Slant-Six Duster would run the quarter mile in about 18 seconds at 75 Nm/h. Hoover's Turbo Duster was running 11.8 at 115 m. That's faster than a 446 pack, faster than a 383 Magnum, faster than most small block V8s of the era, and it was doing it with 40% less displacement and 2 fewer cylinders. But here's where it gets interesting. Hoover wasn't just making power through brute force. The Turbo Slant-Six had characteristics that V8s couldn't match. The long stroke of the 225, 4.125 inches, created massive torque when combined with boost. The engine would pull like a diesel from 2,500 RPM to redline. No lag, no waiting, just a continuous surge of acceleration that pinned you to the seat. The weight distribution was also revolutionary. A big block Chrysler weighs about 670 pounds. A Slant-Six weighs 435 pounds. Add the turbo and plumbing, you're still 200 pounds lighter than a big block. And all that weight sits further back in the chassis thanks to the slanted configuration. The result was a car that actually handled instead of just going fast in a straight line. Track times tell the story. At Ohio's Dragway 42, Hoover's Duster became famous for consistency. While big block cars were breaking parts and overheating, the Turbo 6 just kept running. 11-second passes all day long. The industrial-grade bottom end that Chrysler designed for taxi duty was laughing at boost pressure that would grenade lesser engines. The forged crank didn't care about 450 lb-ft of torque. The solid lifters didn't mind 6,000 RPM pulls. The gear-driven cam timing stayed perfect, no matter how hard he pushed it. The reaction from the racing community was mixed. Old-school V8 guys couldn't accept that a six-cylinder was outrunning their big blocks. They accused Hoover of hiding nitrous. They claimed he had a V8 under there somehow. They demanded teardowns. When they saw it really was just a Turbo 6, they got quiet. Then they got curious. Then they got angry that they'd been beaten by a grocery-getter engine. But the real validation came from an unexpected source, Chrysler itself. Engineers from Highland Park started showing up at Hoover's races. They weren't there officially. They were just enthusiasts who happened to work for Chrysler and happened to be very interested in forced induction. They took notes. They asked questions. They took photographs. Hoover had done something their entire engineering department hadn't considered. He'd proven the Slant-Six could handle boost. Word spread through the Mopar underground. Hot Rod magazine did a feature. Carcraft published dyno results. Suddenly, everyone wanted to turbocharge their Slant-Six. The problem was replication. Hoover's setup was completely custom. Every piece was hand-fabricated. There were no kits, no instructions, no tech support. If you wanted a turbo Slant-Six, you had to figure it out yourself. A few brave souls tried. Most failed spectacularly. They'd use too small a turbo and create massive lag, or too large a turbo and never build boost. They'd run too much timing and scatter the engine, or too little fuel and burn pistons. Hoover's success wasn't just about bolting on a turbo. It was about understanding the complete system, airflow, fuel, spark, cooling, and most importantly, the limits of cast iron and aluminum under extreme pressure. The technical details of Hoover's engine management were surprisingly sophisticated for 1976. He understood that detonation was the enemy of boost. The Slant-Six's combustion chambers weren't designed for forced induction. They had sharp edges and crevices where hot spots could trigger pre-ignition. Hoover actually welded material into the chambers to smooth them out, reducing the compression ratio to about 7.5.1 in the process. Less compression meant more boost potential. He also figured out water injection before it was cool. Using a system cobbled together from windshield washer components, he injected water-methanol mix into the intake under boost. The water absorbed heat, cooling the intake charge by up to 100 degrees. The methanol added octane. Together, they allowed him to run boost levels that should have destroyed the engine. We're talking 25-28 psi on pump gas. That's insane, even by today's standards. The exhaust system was another piece of genius disguised as simplicity. After the turbo, Hoover ran a straight pipe. No muffler, no catalytic converter, just 3 inches of steel dumping out behind the rear axle. The lack of back pressure helped the turbo spool faster and reduced exhaust gas temperatures. It also made the car sound like nothing else at the track. Not the rumble of a V8 or the scream of a small block, but the industrial whoosh of pressurized air being converted into violence. Cooling was critical and complicated. Turbos generate massive heat. The exhaust housing glows cherry red under load. All that heat radiates into the engine bay, heat soaking everything. Hoover wrapped the exhaust in thermal barrier coating before that was a common thing. He fabricated heat shields from stainless steel. He ran an oil cooler for the turbo bearings. He upgraded to a massive aluminum radiator. Every detail mattered when you were pushing an engine this far beyond its design parameters. The turbo itself required special attention. That Caterpillar unit wasn't designed for the thermal cycling of drag racing. Diesel turbos expect steady state operation. Hoover was going from idle to 25 psi in seconds, then back to idle. The temperature swings were brutal. He modified the oil feed to provide more flow. He added a timer circuit to keep oil flowing after shutdown, preventing coking. He rebuilt that turbo more than once, learning each failure's lesson. What made Hoover's build truly revolutionary wasn't just the power, it was the philosophy. In 1976, the muscle car was dying. Insurance companies had killed performance. The EPA was strangling engines with emissions equipment. OPEC had made fuel economy paramount. The entire industry was in retreat. And here was this guy in Ohio showing that performance hadn't died. It had just evolved. Think about the timing. Porsche had just released the 930 Turbo, a $30,000 exotic that made 234 horsepower. Hoover's Backyard Special was making 400 horsepower for maybe $2,000 in modifications. BMW's 2002 Turbo made 170 horsepower and cost a fortune. The Buick Century Turbo Coupe, America's first mass-produced turbo car, made 150 horsepower. Hoover was embarrassing all of them with an engine everyone thought was junk. The influence rippled outward. Within 2 years, Chrysler was experimenting with turbocharged 4-cylinders. The 1984 Dodge Omni GLH Turbo, Carroll Shelby's pocket rocket, can trace its DNA back to Hoover's experiments. Chrysler learned that their engines could handle boost. They learned that American buyers would accept turbos. They learned that 4- and 6-cylinder engines could deliver V8 performance. But Chrysler never turbocharged the Slant-Six from the factory. By the time they were ready to embrace forced induction, the Slant-Six was obsolete. Emissions regulations favored newer designs. The tooling was ancient. The market had moved on. The Slant-Six died in 1987, replaced by the 3.9L V6. But Hoover had already proven its potential. He'd shown that this agricultural engine designed in the 1950s could run with anything from the 1970s. The Mopar performance community never forgot. Today, Turbo Slant-Six builds are a cottage industry. Companies like Aussie Speed make dedicated turbo manifolds. Modern engine management allows precise fuel and timing control. Current builders are making 500, 600, even 700 horsepower from Slant-Sixes. But they're all following the trail Hoover blazed with a junkyard turbo and a welder. What's remarkable is how right Hoover was about everything. His boost levels were optimal. His compression ratio was perfect. His fuel system approach became standard. His heat management techniques are still used. He didn't have simulation software or millions in R&D budget. He had mechanical intuition and the courage to try something everyone said was stupid. The legacy extends beyond just Mopars. Hoover proved that turbocharging could democratize performance. You didn't need a big block to go fast. You didn't need cubic inches or high compression. You needed boost, and boost could come from anywhere, even a Caterpillar bulldozer. This philosophy would eventually give us the Buick Grand National, the Mazda RX-7 Turbo, the Toyota Super Turbo. Every turbocharged performance car owes something to pioneers like Hoover, who proved the concept when nobody believed it would work. But here's what really matters about Hoover's story. He didn't just build a fast car. He exposed a blind spot in corporate engineering. Chrysler had thousands of engineers, millions of dollars, and decades of experience. They completely missed what one guy in Ohio saw immediately, that their economy engine was actually a boost-capable monster waiting to be unleashed. They designed the Slant-Six to be reliable and economical. They succeeded so completely that they created an engine capable of things they never imagined. The technical specifications of Hoover's final setup were staggering for the era. The engine maintained stock bore and stroke, 3.40 x 4.125 for 225 cubic inches, but everything else was pushed to extremes. Boost pressure peaked at 28 psi. The air-fuel ratio was kept at a conservative 11.51 under load. Ignition timing was pulled back to 18 degrees total advance under boost. Oil pressure was maintained at 80 psi to handle the increased bearing loads. Coolant temperature was kept below 180 degrees even during repeated runs. The Schwitzer S2B Turbo was spec'd for engines up to 400 cubic inches, so it was actually undersized for optimal efficiency on the Slant-Six. But this flaw became an advantage. The smaller turbine housing created higher exhaust velocity, spooling the turbo faster. By 2,000 RPM, it was making 5 psi. By 2,500 RPM, 10 psi. By 3,000 RPM, full boost. No lag, no waiting, just immediate thrust. Modern builders using properly sized turbos actually have worse response than Hoover's agricultural unit. The fuel system delivered 45 gallons per hour at 7 psi base pressure, rising to 35 psi under full boost. The Holley 650 was jetted with number 82 primaries and number 92 secondaries. The power valve was blocked off with enrichment handled entirely by the boost-referenced fuel pressure regulator. The accelerator pump was modified to deliver a longer shot, compensating for the turbo's initial spool-up. Every carburetor circuit was recalibrated for pressurized operation. The ignition system was equally exotic. The MSD6A delivered 535 volts to the coil primary, creating 45,000 volts at the plug. Spark plug gap was reduced from the stock 0.035 to 0.025 to ensure consistent firing under boost. The plugs themselves were 2 ranges colder than stock, Champion RJ12YC instead of RJ14YC. The distributor was locked out at 18 degrees total advance, with no vacuum or mechanical advance. Timing was controlled entirely by static setting. Hoover's engine made peak horsepower at 5,500 RPM, but it would pull cleanly to 6,200 RPM. The stock valve springs were retained, proving that the Slant-Six's valve train was overbuilt from the factory. The hydraulic lifters were replaced with solid units from a 1960s version, eliminating pump-up at high RPM. The cam was a mild Iski grind with 0.450 lift and 256 degrees duration, actually smaller than modern turbo cams because Hoover understood that boost makes up for duration. The bottom end remained completely stock. Stock rods, stock pistons, stock bearings. The only modification was balancing the rotating assembly. This wasn't high-tech balancing either. Hoover did it himself with a drill and a scale. But it was enough to let the engine survive 6,000 RPM pulls that would have scattered an unbalanced assembly. The fact that cast pistons and rods survived 400 horsepower speaks to Chrysler's over-engineering. The legacy of Hoover's turbo Slant-Six extends far beyond just making power. He proved that forced induction could save the performance industry when displacement was dying. He showed that complexity wasn't necessary. Simple systems properly executed could outperform sophisticated engineering. He demonstrated that seeing potential where others see limitations is the essence of innovation. Today, when every manufacturer offers turbocharged engines, when Ford's EcoBoost makes 647 horsepower from 3.5 liters, when even economy cars have turbos, remember that it started with guys like Tom Hoover, guys who looked at an unloved engine and saw unexplored potential, guys who weren't afraid to try something everyone said was impossible, guys who understood that engineering isn't about following rules. It's about understanding principles and then applying them in ways nobody expected. The Slant-Six died in 1987, but Hoover's Turbo 6 lives on in every turbocharged performance engine built since. Every time a modern engineer decides to add boost instead of displacement, they're following Hoover's philosophy. Every time an enthusiast makes V8 power from fewer cylinders, they're proving Hoover was right. He didn't just outsmart Chrysler, he outsmarted an entire industry that believed bigger was the only path to better. So the next time you hear a turbo spool up, remember Tom Hoover and his junkyard Caterpillar turbo. Remember that innovation doesn't always come from corporations with massive budgets. Sometimes it comes from a guy in Ohio with a welder and an idea everyone else thinks is crazy. That's the beauty of engineering. The best solution isn't always the obvious one. Sometimes it's tilted 30 degrees to the right, makes weird noises, and comes from a bulldozer. What's the craziest engine swap you've ever seen actually work? Let me know in the comments, and don't forget to subscribe for more stories of engineering rebels who changed everything.